Our particle moves on the y-axis at the time, that's position, describes the motion of the particle at time equals 1. So it's asking something about velocity and whether the velocity is increasing and decreasing. So the first thing, velocity, is the derivative. So I have to find the derivative of this, 3t squared minus 8t plus 4. Okay. We're figuring out when time equals 1, so I'm going to plug in 1 into this. 3 minus 8 is negative 5, plus 1 is negative 1. All right, so my velocity at 1 is negative. That means, all right, if I'm thinking about the y-axis, up is positive, down is negative. So my particle is moving down the y-axis. So that eliminates C and D. And then is the velocity decreasing or increasing? All right, well, to figure out this function, if something's increasing or decreasing, we have to take its derivative. So it's actually going to be acceleration, but the derivative of velocity is going to be 6t minus 8. And I plug in 1 again, and I get negative 2. So my function is velocity is going down, and the acceleration, or the velocity, is increasing at negative 2. So it's already negative, and it's going to keep going down, which means it's going down with increasing velocity. All right, so it should be B. Now, if we know the integral from 1 to 4 of f and the integral from 1 to 4 of g, which finally can we not be determined? All right, well, the first one, if you compare this to the first part, the only difference is those bounds are switched. And if you switch the bounds, you just get the same value but negative. So that would just be 2. All right, with the constant out in front, you can just bring the constant out. And this one would be 24. D is really just a and b added together, and we can split up integrals over addition. So that would be 26. And since I figured out answers for all those, I can't do C. Right, C has this multiplication between them, and the integrals don't behave nicely with the multiplication of these two different functions, but it does with addition. All right, so in this case, you cannot do C with that information. All right, for any real number, what is this limit equal to? Well, if you see kind of an h going to 0 and an h, this kind of reminds me, because I've been doing this for a while, but maybe it'll remind you too of this formula. Which this is the formula for the derivative. All right, so this is just the formula for the derivative, and you can see that f of x is what goes second. So it's saying f of x is sine of 2x. And then this whole thing is equal to its derivative, so we just take the derivative of this, cosine of 2x times 2, and our answer is D. So once you know what you have to do for this problem, and that the problem is literally just take the derivative of sine of 2x, it becomes fairly straightforward. I would have to kind of relate this formula to our definition of our derivative in order to know that's what you have to do. All right, shown above is a slope field for which of the following differential equations. So again, if you see differential equations, that was that kind of one optional thing that you had the chance of doing when we were doing substitution. All right, so you could just kind of skip this if you see something about differential equations. If you actually know how to do the other 27 or 28 questions, that's fine. But a slope field says basically you just plug in the x and y value. So this would be the point 2, -1. You plug that into your equation, and that tells you the slope of the tangent line at that point. All right, and then we know positive slopes are going upward, negative slopes are going downward. All right, so for instance, if I plug in 2, -1 into this first one, I'd get absolute value of 2, 2 plus -1, so absolute value of 1 is 1. So for that point, this slope field should definitely have a line going up to the right. All right, so that's the basic idea of what a slope field is. And then which one of these is going to match with what we have? Well, if we look at the kind of pattern of this slope field, all right, if you look at here, all of these are just straight 0. So it doesn't matter what the x value is, so any x value, all right, and when y is 0, we should get 0 for the horizontal slope field. Well, for this one, I can make x 3, and I should get 3 and not 0, so a is out. For b, I can make, say, x1 and cube it, and you get 1, which is also not 0, so b is out. So just this line across the middle there with all these horizontal tangents when it's 0 tells me that a and b have to be out, because if I plug in some random x and y equals 0, I don't get 0 out. For these bottom two, if I plug in the point like 2, 0, I get 0 cubed, 0. Alright, so those two work for that fact. Alright, now I'll just try some other ones. If I try, say, this point here, 2, 1, which I'm basically just plugging the y value because there's no x value. So if y is 1, these are both 1, so that doesn't help me. If y is -1, this one is -1, and this one's +1. If I look at -1, that line's going that direction, so it should be a positive slope, which means D has to be the right answer. The base of a solid is the region in the first quadrant bounded by all these things. All right, so our xy axis, e to the x equals 1, and it's this region. All right, for the solid, each cross-section perpendicular to the x-axis is a square. All right, so we've done problems like this before. We kind of have this pi r squared because we're doing some solid. All right, but this is because we're doing a rotation around, and when you do a rotation around, all your cross-sections are circles, and that's the area. All right, for this one, a square, the area of a square is just the side length squared. So our integral is going to add up all these squares together. All right, well, we start here at 0. We end at that horizontal line, vertical line 1. And our side length is this gap, right? Because then we're going to have a square coming off of that. Right? Is that gap, and that's the equation, y equals e to the x. All right, so this is what we're trying to solve for this equation. All right, knowing that the volume of a square, the area of a square is just squaring the side length. The side length is coming from e to the x, and then the appropriate things. So simplify first. Again, the fundamental theorem says I'm going to take the antiderivative of this and evaluate it from 0 to 1. So I plug in 1 first. Subtract when I plug in 0. And you can see that exactly matches with B. The graph of the piecewise linear function is shown above. What is the value of 0 to 12 f prime of x dx? All right, so this is the derivative function we're talking about, but they only give us the graph of f. All right, so there's a couple ways you could do it. Is you know that the derivative function is going to be the same value for this whole piece. All right, so that whole piece looks like it's slope -1. This whole piece, let's use a different color, is up 3 over 1, so that's slope 3. And this piece again is -1. So you're going to end up getting a graph for the derivative. And it goes, all right, switches at 7 and 8. All right, so up to 7, it's just -1. At 8, it jumps up to 3. And from 8 to 12, it's -1 again. All right, and the integral is just code word for the area. So I'm finding this area, that area, and that area. All right, this one has area -7. This one has area 3. This one has area 4. Oh, sorry, -4. All right, add all those together. -11 plus 3 is -8. So that's one way you could do it. Basically, make the graph of the derivative and add up all those areas. Remember, if it's below the x-axis, it is negative. The other way is remembering this accumulation of change formula that we've used a few times. That to get from the value a to the value b, you add this integral of the derivative. Well, for our problem, this is 0 and this is 12. All right, to get from the function value at 0, which is 4, so to get from 4 to the final value at -4, and how do I get from 4 to -4? I have to subtract 8. So since I'm subtracting 8, that's another way of knowing that's the answer. All right, a little bit less work that way, but you have to know that accumulation of change formula and how that's related to your original function f.